The purpose of this lab is to synthesize alkenes via E2 elimination of 2-chloro-2-methylbutane and the E1 elimination of 2-methyl-2-butanol or T-amyl alcohol. The products will be isolated via fractional distillation and analyzed via bromine and Bayer test. Because there will be a mixture of alkenes, the ratio of each will be analyzed via GC. Before beginning the experiment, proper safety equipment such as safe lab attire, goggles, and gloves is mandatory and must be worn at all times. The first experiment in this lab is the E2 elimination of 2-chloro-2-methylbutane. Potassium hydroxide pellets were added to a round bottom flask. Using a graduated cylinder, 1 propanol was measured and added to the flask. A boiling stone was added and the flask was clamped to a ring stand. The solution was gently heated to allow for the hydroxide to dissolve. After the hydroxide mostly dissolved, it was removed from the heat and was placed on ice. The SN1 product from the last lab was added via pipette. The flask was then clamped to a ring stand. A Hempel column was filled with Raschig rings like in fractional distillation. The water was also attached like a condenser. This for now will serve as a condenser and the fractioning column will be used later during distillation. The joints were greased to prevent them from sticking together. The condenser was attached and the water and heat were turned on. The reaction was refluxed for an hour. After an hour at reflux, the heat was removed and the flask was allowed to cool. Do not turn off the water. Once cooled, the remaining fractional distillation was assembled with the still head attached to the Hempel column that was already filled with Raschig rings. The condenser was attached to the arm of the still head, followed by the vacuum adapter. Keck clips held everything together. On the receiving side, a pre-weighed round-bottom flask was placed. Make sure it was pre-weighed to be able to calculate the percent yield. Ice was then placed under the receiving flask and the thermometer adapter was added. The heating mantle was raised and the water was turned on. The distillation was continued until the still head temperature reached 45 degrees. The flask was removed and masked. The percent yield could thus be calculated by taking the difference of the empty flask versus the full flask. The second experiment is the E1 elimination of T-amyl alcohol. To begin, T-amyl alcohol was measured in a graduated cylinder and added to a round bottom flask. 6 molar sulfuric acid was then measured and added to the flask. A boiling stone was added and the flask was clamped to the ring stand. The fractional distillation apparatus was assembled over the flask, similar to the previous fractional distillations. The receiving flask was again pre-weighed and put on ice. The thermometer adapter was then attached and the water and heat were turned on. The product was collected until the still head temperature reached 45 degrees Celsius. Once done, the flask was removed and masked so you can be able to calculate the percent yield. In 6 small test tubes, about 1 milliliter of water was added to each. A small amount of the E1 product was then added to 2 of the test tubes. An equally small amount of the E2 product was then added to another 2 test tubes. The last 2 test tubes were kept empty as a control. Using a pipette, a small amount of potassium permanganate solution was added to the E1, E2, and control test tube. The results were recorded. Are there any alkenes present? A small amount of bromine solution was added to the remaining E1, E2, and control test tubes. The results were recorded. Remember, there are 2 types of alkenes that were formed, the Zaitsev and Hoffman. Can these tests help decipher which one was made? Using GC, we will determine the ratio of Zaitsev to Hoffman products. Using a microsyringe, about 2 to 3 microliters was injected into the GC. The peaks were then recorded and integrated. This was repeated for the other products. Are there 1 or 2 products present per reaction? Can you determine which one is which? Is one product favored over the other and why? Overall, 2 elimination reactions took place. Each formed 2 different products. You should be able to calculate the percent yield per product. You should be able to determine whether the tests were able to determine if alkenes were successfully synthesized and if they were able to differentiate between Zaitsev and Hoffman products. Although through GC, you should also be able to determine if there are any preference towards one of the products. If there is a difference in ratios between reactions, determine why.